Hey, so this recording is going to be on kinetics. We're going to go through a quick review and then we're going to do some free response questions along with some multiple choice answers and questions. So, what is chemical kinetics? Chemical kinetics is the study of how fast a chemical reaction occurs. So, this just has to do with speed. Now, there are several important factors that affect rates of reactions, such as the physical state of the reactants, the concentration of the reactants, the temperature of the reaction, and again, the presence or absence of catalyst. So once again, that's the physical state of the reactants, the concentration of the reactants, the temperature of the reaction, and the presence or absence of a catalyst. The goal is to understand the chemical reactions at the molecular level. Now, in regards to reaction rate, that's pretty easy. The speed of a reaction is defined as the change that occurs per unit of time. So in this case, it would be the change of concentration over the change of time. It's often determined by measuring the change in concentration. The speed of chemical reaction is the reaction rate. Again, it's fairly simple. Average rate is the delta or the change in concentration over the change in time. Okay, so remember, this is very important, that in most chemical reactions, we will determine that the reaction rate by monitoring a change in concentration. Now, we can only do this experimentally. We can't look at a reaction and automatically say what the rate law is. So, which I'll get to later. But most importantly is that you guys understand what the term instantaneous rate is. Instantaneous rate is the rate at any instance in time. It's pretty much like if you can imagine a graph, a slope of a straight line tangent to the curve at that instant. So instantaneous rate is different from the average rate. Be careful, because the average rate is the rate, per the entire duration. Instantaneous rate is the rate per that exact instant. So let's talk a little bit about reaction rates in stoichiometry. So I know everything that I've said is kind of obscure and a little bit over the head right now, but let's give you an example for reference. Okay, so let's say that we have C4H9Cl plus water yielding C4H9OH plus HCl. Just for shits and giggles, C4H9Cl, if we were going to name it, it would be butane. Actually, this would be chloride. Butanyl chloride, I think. It's been a while. Ignore that. So, the rate of appearance here. You guys can see this. C4H9Cl water. Okay, easy enough. Now, in regards to the rate of appearance, the rate of C4H9OH, which is butanol, is the rate equal to the negative change of C4H9Cl to the change in time, which is also equal to the positive change of C4H9OH for change in time. So, this was a 1-to-1 ratio, but what happens if it's not a 1-to-1 ratio? Okay, this is very important. So, for example, if we had a reaction like 2HI gas going to H2 gas plus I2 gas. Again, that's 2HI gas going to, right? Okay. Now, hope you got that. Now, this is a little bit different because the rate, it's not 1-to-1 anymore. So the rate is going to be the negative 1/2 of the disappearance of hi to time is equal to h2 t. Don't worry, I'll pull this up. Butanoic chloride. That's it. Sorry. Here we go. Okay. That's because it's 2hi. Okay, that's very important. It'll come up later on in some problems that we're going to do. So keep that in mind. Alright, so if you like to generalize this a little bit, it's actually pretty easy. If we had a reaction that's like little a plus big B, little b here. So we have a reaction that kind of looks like this. Right? This is the generic form for a lot of our problems. Right here. Now, we can then do rate is equal to the change of negative 1a equal the negative 1b change of b over change in time. 1c delta change c over delta time. A delta change d over delta time. So it could look like something like this. Okay. Alright. So that's the generic form with stoichiometry involved. So let's go on to concentration and rates. In general, rates increase when reactant concentration is increased, decrease as concentration of reactants is reduced. Now that's pretty much that's pretty easy, right? So let's take a look at a reaction real quick. So let's say NH4 plus NO2 minus yielding N2 plus 2H2O. Alright? Now that should be pretty easy. Let me guess to see. Okay. So now what we're going to do is I'm going to ask you a couple questions, and I hope you guys follow along because this is really general stuff that you guys really need to know. So we measure the initial rate. The initial rate is the instantaneous rate. It's always going to be at time 0. You find this at various initial concentrations of each reactant. So we have to be careful here because everything has to be experimentally determined. When I ask you as NH4 doubles with NO2 minus at constant, the rate doubles. So then you know what kind of ratio this is. This is a 1-to-1 increase, right? So then we can conclude that the rate is proportional to NH4 plus. When NO2 minus doubles with NH4 plus constant, the rate also doubles. So this is stuff that she's going to have to give you because it's not stuff that you would know naturally, you just wouldn't. So in other words, our rate law is going to be K, the concentration of NH4 plus, times the concentration of NO2 minus, all to the first power, which means that the overall rate law for this is 2. Now again, this is very, very, very generic. It's not even close to what you guys are gonna have to do, but that's pretty much the basis of what kinetics is. You guys should know that the overall reaction order is just the sum of all the exponents together. In this case, it's 1 and 1. 1 plus 1 is 2. For the units of the rate reactants, rate constants, I'm sorry, it always depends on the overall order. For example, if it's a second order, then it's going to be units of rate, which is always going to be molarity over seconds, and it's over units of concentration, which in this case, if it's second order, it's going to be big M squared. So you're going to have M over S over M squared, and that's going to give you this one. So a very easy, and people miss this all the time, is that the rate constants, so this is for second order, the rate constants, uh, basically they're units, right? A lot of them miss this because they don't understand that it's entirely dependent on the order of the reaction. So so let's see here. I'm running out of time, so let's do. I'm gonna have the change of concentration with time in my next video. One second.